All right, now it's official. Welcome everyone to the Smoky Mountain Amateur Radio Club monthly meeting for March. I'm Jeffrey Mark, your club president. I'm awfully glad to be here. Just want to make sure before we get too far along that we have somebody to act as secretary. Anybody in the room? Anybody on Zoom who can act as secretary? All right, no problem. We're recording this, and so I'm going to use AI to go through the transcript, and we will have the smartest secretary ever, and it will misspell everybody's name. It will be wonderful. Yes, sir. No, you don't. No, I will take care of that afterwards. All right, opening remarks are basically welcome. We've got a great presentation today. Dave Kaun is going to talk to us all about antenna grounding, and after that we will have the actual business meeting. So without further ado, Dave, the floor is yours.
Okay. Now, all of you, no sleep, put your heads down. I hope you did that earlier. I mean, this is such an exciting subject, right? Let's see if they can get the slides up. Okay. And if all things work right, I'll actually be able to advance them. I even got the old name of the company I used to work for on this thing. Are we set? Okay, amateur radio grounding, and it's kind of an interesting subject. It's more interesting after I took 2 hits, which I'll talk a little bit about later since I've been here, and fixing the station afterwards, some of which I'm still doing. And I've been involved with grounding for quite a while in the commercial side as well, and some of that's introduced in this as well. These slides have all been put on the website. There's a lot of detail in them. So I'm going to go ahead and just say, you don't have to read it all. I'm not going to read them. I've never done that in my life when I came. I used to teach this stuff using PowerPoint. So it's one thing I always say is don't read the slides. But we're also going to talk a little about surge protection and a little bit about ground rods and the like. Okay, guess what? You may be doing it because no advance. No. So let's see if you can advance it for me. Try it again. Nope. We tried it before. So just go ahead and give me an advance if you can, please. What'd you do between? Okay, here we go. This is. Okay, first of all, there's 3 kinds of grounding that you need to be aware of. Number 1 is the one you probably all thought about, was safety ground. This is the ground the National Electric Code talks about. It's the one you're building. It's that green wire that comes up to your outlet. It's safety. It has to do with safety. It never carries any current unless it's bad current. Never good current. That's really what to think about. There's our signal common mode ground, which we're all going to be interested in, especially if you put your mic up to your face and you start feeling it on your lips or your fingers as you're keying or whatever. We'll talk more about that. And then lightning protection ground. That fun situation of getting a lightning stroke. And I've had 2 of them since we've been here. Okay, and all grounds, all 3 of these, and any other grounds you do inside that building must be connected together or bonded. You're going to hear about bonding a lot through this. You're going to get tired of the word bonding. I don't know if you've heard of bonding before, but you're definitely going to know what bonding is before we get done with this presentation. And that bonding means we're going to electrically connect everything together so it's all at the same voltage potential all the time. Go ahead. Okay, the basics of grounding. This is kind of an important slide. If you take anything away from this, get this slide and take a look at it. Go back to it a few times if you need to. This is not going to read it, but the first thing is a ground conductor shall never carry any operational current. Nothing. It's just there. It's there for the purpose of safety. It's there for the purpose of killing or taking current to the earth. and it's not to carry anything other than that. That's the whole intention. The size of that conductor is important. Its size, it needs to go to to carry the intended current that might have to flow through it. Number three is the structure is there's only one ground point in a structure. Everything starts and stops to that one point. Everything is referenced to that point, and that point is referenced to the earth. One point. And that's typically at the ground. We're going to get to that here in the next slide. I didn't say the next one to go to, though. Thank you, Bob. Okay, you're reading ahead of me. The safety ground, National Electric Code. You can go out online and find this if you want to. It's there. Most places have accepted the code in one version or another. Sometimes, locally, they'll go back and accept one that's 5 years old or even older. But their National Electric Code is pretty well an accepted standard. RF grounds, on the other hand, are typically, the military has them, the electronic communications companies like Motorola, Harris, they've all adopted their own. You've probably heard of R56, maybe you have or haven't. And then lightning grounds, we've seen lightning rods on buildings. That whole idea of getting the earth connected to get lightning dissipated. And again, in yellow, everything is equalized to the earth. That's a really important part of all of this. What is earthing? That's another term kind of you used to hear a lot of. In fact, there used to be a symbol for it that was used. You don't see it that much anymore, but it's kind of like fingers going down like this to the earth. It's connected to the ground once it's there. It's a physical massive conductive mass of the earth. That's what the whole idea is. Whatever's necessary to get to the earth, and depending on the earth you're at and where you're at, the amount of necessary conductive material in the mechanism of getting to the earth is going to change how conductive that might be. Go ahead now. Thanks. Here's what's happening at your house. You have an electric panel sitting there. You have a disconnect in it. The main electrical comes in to the far left, that small box, that's where the meter is located. And you notice there's no ground in there at that meter, inside the meter box itself. But inside the main disconnect, there's a bar on the far right. And that's where the neutral power connection comes in from the outside. It's that white wire coming in from the meter. It comes in all the way from the transformer that feeds your house. And that's where there's a ground connection to the outside. That's the only place where the electrical ground and neutral connect in a building, in the disconnect, that point only. If you have another place where there's another control panel or another circuit breaker panel in the house, those two are not connected. The ground remains separate from the neutral. On the lower right side, you're going to see something called a UFR ground. This is commonly used to cut corners and to reduce the size. They don't put a post in the ground. They don't put a steel ground rod in. They'll connect to the rebars that's in the foundation underneath your house. Because the National Electric Code doesn't require the kind of ground for electrical ground as we do for the RF side or for lightning. So they use the rebars to do that. I found that to be the case at my house. That was part of the problem we had. When you get to the end, I'll show you how many ground rods I now have to replace that. Go ahead, Bob. Okay, next thing, bonding. Here we go again, bonding again. If you look at this, you're going to see, again, reference back to the National Electric Code, and it says if you have separate ground rods anywhere at your house, they need to be bonded together. I don't care if they're outside the house. I mean, ground rods are always outside, right? And they need to be connected together some way or another with a large enough conductor to carry the current between them and cause them to be at equal potential. And you can see in this case, that drawing has been copied out of the National Electric Code. You can see the disconnect on the far left, and you can see the right side, and you can see that bonding wire that goes between them. Now, the ideal would be to put that bonding wire outside your house, to run that cable outside. Personally, you'll see when you get to mine, I can't do it. I got concrete all around I got patio, I got driveway. I can't do it, so it runs through my crawl space. It lays on the on the ground in the crawl space, but it runs through the crawl space because there's no way I could easily get it around the house. I wish I could have when we were there, but it was it didn't happen. Go ahead. Okay, Polycom is a, should have been Polyphaser, not Polycom. Polycom's a different company. My fault on that. I didn't catch that one. Now you see them up on the slides. That's the only time you catch these things. Polyphaser is a company that makes grounding equipment and surge suppression equipment in the commercial industry side. You'll see it quite often listed. This is a drawing right directly from them. And you'll see all of those little red dots. Those are all ground rods that they placed in the ground around a tower to try to get the mass of the earth connected as much as possible to get that resistance down, to get as good a mat, a good place to get that grounding signal in. And you'll see that over on the lower right. Bob, this is actually a 3-step. So do me one more, just one, please. Okay, multiple ground rods used to lower the impedance of the earth. Number 2, Bob. Notice up there, note number 2, the AC is a ground. There's a ground reference to the system like we just talked about. And number 3, Bob. Okay, the bonding ground radial interconnects your shack with your tower. Get those two together. And the reason that will become very, very clear, especially when I go into the lightning area toward the latter part of the presentation. It has to do with the voltage potential that exists of lightning hitting a tower and what it's like in relation to the voltage at the house and trying to get those at the same voltage level. That's the whole idea behind it. Okay, Bob. Okay, here's another shot from another company. Pardon me. And you'll see in this case the coax is actually grounded with a bonded, I should say not grounded, bonded as it leaves the tower. You can see the rebars in the foundation of the tower have been bonded, and you can see the bonding wire into the house or into the shelter building, whatever that means, also has a bond. And a couple of different mechanisms show us to see how that's done. And there's actually kits to do this, depending on the type of coaxial cable you're using, of making sure that everything stays at the same potential. Go ahead. Another drawing, and here again, multiple bonding throughout, and hit the next one, Bob. Okay, this one goes through each of those numbers. If you want to look this up when you get home and get a chance to look at these slides in detail, each of these numbers references one of those ground points, and you can see all the ground rods that are at the tower. At the number 14, I think it's number 14, the one that runs across there, is the coaxial cable showing that. Number 15 is a cable running across. Now, depending on how far your tower is away from the house, cardinal kind of give and take rules 50 feet. If you start getting the tower more than 50 feet away, you typically don't have to tie those two together. There's enough impedance that has occurred in that cable that it doesn't give you a good enough importance to have that ground across there. Typically in the commercial sites, we seldom ever see compounds big enough that the towers are that far away anyway. But you can put it in, it doesn't hurt anything, but you don't always see that if it's more than 50 feet or more away from the structure, separated. They aren't necessarily, that number 15 isn't in place. Bob, go ahead. Okay, here's the interesting one, the 2 slides, and I'm going to talk on the one on the right there first. The one on the right, the aperture operator that put this in has used some bronze clamps like you use for the ground rods, clamped over top of his coax as they leave the base of the tower. He's trying to get his coax at the same voltage potential as the base of the tower. This does 2 things. One is an equal potential of the coax to the tower, and the second is an RF grounding scheme to reduce common mode currents and noise. Very effective. It's done commercial world all the time. A lot of hams don't do this. I don't have a tower anymore here, so I didn't. But back in when I was back in Wisconsin, I did have, my lines were all grounded before they ever got in the house, and so they were, that was done. Excuse me a second. The picture to the left, you'll see the ground rods that he's placed. And we're going to get into this a little more too. Those ground rods are great. They're wired and bonded to the tower like they should be, but it's a little problem. They're too close together to be of value. The ground rods, spacing between the rods to be of full value is they need to be separated by the length of the rod apart from each other, because that's how the ground rods work. If you get them any closer than the length, than their depth, or how deep they're going in the ground together, effectively, you don't have the full capacity of the ground rod. You've lost part of it. So separate them out further, which is much more valuable to the process of what you're putting in the ground. I mean, you're buying a rod that you're going to pound in the ground and never see again, hopefully. But get them out a little ways away from there. Okay, Bob. And common grounding mistakes. Well, I thought I'd throw this slide in about right here. Not enough rods, not enough ground rods, which I felt I was one of my problems after my first lightning strike. No surge protection at the base of the tower mast. Well, I had a mast pipe, but I didn't have a tower here anymore, but I now have surge protection at the base of where any of my cables hit the ground before they travel into or toward the house. Site grounds not being bonded together. Again, I did have this in place, but it's something that we talked about, and the ground wire's too small. It's kind of accepted practice in the amateur community to use no lower than number 6 stranded wire for grounds. If you can afford to put something heavier in, that's great, but nothing smaller than number 6 in diameter. And you need that surface area of the wire itself, the circular outside of the wire, to get a good mechanism for ground. And I use number 6 throughout across. I mean, today copper is not cheap, so understand that. But then again, where's your equipment that you want to replace after a hit? The bends are too tight. Lightning, when it hits, likes to follow a nice curved path. It doesn't like bends. I actually did a commercial job where I was up on the 10th floor of a university building in Iowa. And when I was up there, the mechanician that was up there that took me to the roof of the building said, "Yeah, every time we get lightning up here," he says, "my elevator goes out." Well, there's a ground rod, a big element, a ground electrode going up in the air right there on that building, a blank honors building, they called it. And every time they got a lightning hit on that thing, it was mounted on the side of the elevator equipment room. I said, "Well, open the door of the room." So he opened it, I looked inside. There's the elevator control panel on the other side of the wall. Well, what had happened is they had a huge cable that probably when it was installed was nice bends going down through, all the way down through the building. However, water would seep into that cable when it rained, and it would actually get the floor ceilings wet on the floors below. So they had modified the cable by making some tight bends so it would drip up outside that building before it ever got down below, and then on the last spot filled it all full of silicone best they could to stop that dripping. Well, what he did is he put in a great inductor, and the lightning never went past that point. So guess where the lightning went? Into the building, into the controller. They straightened it out. I contacted their manufacturer, and he said, took a picture, sent it to him of that lightning system. And he said, well, they just null and voided their lightning rod, because that's not, you break a rule on the installation, you effectively null and void what you have. So he contacted them, they straightened them back out again, and lo and behold, never had any problem, at least that I heard of afterwards. But there's another problem too. I don't know if you know that the sky is gray, not blue. We had to paint all the microwave dishes on the roof of the building sky blue per the committee on campus. Stuck out like a sore thumb. They left, we went back to gray. But I don't know, people, there's all sorts of stuff you run into. I drove all the way down to this from where I lived just east of Minneapolis, met with this committee of older people that all had, retired from the campus. They were bound determined it had to be sky blue. Okay. And no single point ground for the shack. We're going to get into more of this, but it's very important. And the connecting of dissimilar metals. Remember I said I was going to read a slide? I'm reading this one. Go back and look at it again. Review it a few times. It's a good checklist. My last item on the checklist is a disclaimer. You're on your own to do what you do. I'm not telling you what to do. I'm just suggesting and telling you things that work, other people have found that work, that I pulled into these slide bank that you can look at and suggest you do. Next one. Okay, let's move into the shack itself. Create a single mode, common mode ground point. Get everything to a single point that you can with as short a cable as possible, and tie that to your structure tower ground. You want to get these cables as low as you can so that it's a low impedance point to tie it together. People say, well, I've got coax and it's all grounded together. Yeah, that's true, but not the equipment chassis is not grounded through the coax. Take a DC meter, it is, but from an RF standpoint, it's not. So you do need to have that ground in there if you want to get a lower impedance and get the impedance connection down and get your common mode issues taken care of. Go ahead. Okay, Skyward Forum is another site out there. You can see how this particular ham has done. He's put a ground bar on the back of his desk as high as possible, close to his equipment, with jumpers to the gear. Again, get those jumpers short, get them up there, get that equipment tied together as close as possible. And you can see, he's, just to make it easy, he's got jumpers all set to go on. He doesn't have them all connected, which I wish his picture would have shown that. Other people I've given this to point out, yeah, but the jumpers aren't connected. Yes, I know. I saw that, but I couldn't do much about it because I didn't take the picture. I just stole it from somebody else. And the cable, of course, you can see the large cable to the strap or to the shack single point ground. On the right is a photo from my originally my own shack where I had a copper plate on the back behind my radios. I have switches located there. This is what I had. I've since replaced them. But this switch is a switch that has 3 positions to it. A antenna, B antenna, and the middle is ground. So when I'm not doing anything in there, I always reach up. My last thing I do and switch it over to ground. So I'm grounding the antennas right here, and this is mounted on that copper strap, which is grounded. That's only one of the places that this happens that I try to get it to. I've replaced them with better, what I think are better switches, which I'll show you as I get farther into this presentation. Okay, Bob. Here's another option some people have used. They run a piece of copper pipe across the back of their desk and using straps across there and take straps up to their equipment. This is a kind of a top view and a side view both, and you can see a short length of cable to the ground rod itself, and you've got a tower ground. And the only thing about hose clamps, understand that once in a while you need to go back and retighten them. They like to loosen up. They don't like to stay tight. So it's kind of a good idea that kind of on a preventive basis, loosen them and tighten them again, loosen them and tighten them again, you know, on a sort of an annual basis at least. For some reason, I don't know why that is, but they don't like to stay tight unless they're on rubber hose. Then they do a pretty good job, but you're not tightening on the rubber, you're on metal to metal. Go ahead. This one I threw up there just because it has a common mistake where you're same copper tubing, but here the ham put it across the floor rather than up near the equipment. So he's got long wires reaching down to the floor, which effectively, remember, that ground that you created is part of your antenna system too. So you want to get that cable up there as short as possible and get it up behind the radios, not down near the floor. So that's a piece of that. There's no bonding cable to the building that I can see in the drawing, no indication of such, which there should be. And everything going to a common point would be a better way to do this if you possibly could. Go ahead. Okay, here's one that people have said, and I added this from my last, I did this a few years ago. What happens if the earth potential is a long ways away from my station? I'm on another floor of the building. I can't get to the ground because it's a good distance away. Remember what I just said about your ground is part of your antenna, especially at HF frequencies. So W8JI has come up with a solution here of actually using a piece of RG8 coax, whatever length, and then calculating. You can search out W8JI and find his calculations to create a tuned stub ground to get rid of that problem of being able to have a longer ground cable to Earth than what you could have. And this really starts affecting you when you get around 30 feet. So if you got them to run more than 30 feet to a ground rod, your first major ground rod, this is a potential solution. I've never tried this, but it was one held in one of the magazines. So gave him credit for it. Throw it out there for what it's worth. Okay, second. Yeah, move it. Go ahead. Another one. This came from Mr. Tim here. He said, what happens if you can't get to a ground? What do you do then? Which, of course, if you live in a apartment building or a condo or someplace or on a floor, or you can't get to a ground. What do I do if I'm trying to do HF? Well, you got to have common mode of some kind, some sort of a complex way of having a counterpoise for that HF side. And one solution, which is put a copper mat or a conductive mat of some kind under your carpeting, around your baseboard, something in there to give a counterpoise to your radio system and your antennas, the antenna you use. And Tim, what are you using?
A window screen. Where is the window screen? On the carpet.
So he has a window screen on his floor to give him his counterpoise. So there's a solution. There's a solution to these things, but that's one possibility as a way of accommodating the situation. Now, you're not getting it ground because the green ground screw off that electrical is certainly not going to give you what you need. Remember, that's just a safety ground. And the pipe used to be able to connect, when I was back in my days of early amateur radio, there was a bathroom off the wall next to me, and I just kind of went through the wall and connected to the copper pipe. Get my ground, but now we don't put copper in it, we have now plastic. So that doesn't do any good. So here we go. Go ahead, Bob. Okay, now the fun one, lightning and earthing. Let's see, how do we take care of this? That's all right, you can go to the next one if you want. That was just a kind of a leader slide. First of all, this is a national map that's been created that shows about how many strikes a year we get throughout the ground. And you can see down in Florida, they're getting around 70 a year. We get around 55 strikes a year in our area. In the upper right corner, this is a shot looking down, and this is a culvert with gravel at the base of it. The black on the top is where the lightning hit in the lot adjacent to me. Now, how do I know that's where it hit? Because the neighbor was standing in his driveway on a beautiful sunny day, looking towards Sevierville, when the lightning hit. And that stroke hit that spot. If you went out there and looked, there's a pinhole down through that top plate of rock, and the black is still there, where it hit the culvert. I talked to some cable guys who said this is not uncommon in this area, because the culvert many times has water sitting in it that hasn't soaked away, and so it's beautifully conductive to the area, because we're in clay. And so they do see this happen quite often. Now, the secondary hit, which we're going to see in a few seconds how that works, actually hit the cable company and power feed, and that's how it got in my house. It literally burned up the cable company cable coming into the house, took out the cable modem, took out the router attached to it, took out the Wi-Fi router, I should say. I had everything connected with Cat5 cabling. So I lost the TV, a computer. Everything I had connected, printer, everything that was connected to the computer was all wiped out. And I was sitting there when that hit. Now, according to my neighbor, the sun was shining. Just he could see clouds way off to the east. There was no winds, nothing. Crack. I heard it, I felt it, and I couldn't hear for a little bit. I mean, because the loud crack was so loud in my, and the smoke came out of my modem. So I ended up replacing all the cable. Cable company replaced the cable. They replaced the outfit, the breakout splitter out at the cable line, overhead line, the cable into the house, and ultimately the cable, the unit lightning arrestor on the outside the house, and the cable through my house. All that got replaced, plus all the stuff I had to replace under insurance. So today everything is Wi-Fi. I don't have any. I don't have any of the Cat 5 connected anymore. But I'm also on T-Mobile wireless, just to get away from having one more cable coming into the house. I also now have a surge suppressor, which I'll show you in a second. I don't think that would have helped any for this. Go ahead, Bob. Lightning is a high-frequency event. Charges in the cloud build up, forming a highly negative particles. Objects are in the ground, they're positively charged, and there's a step leader occurs, and then bang, it connects. At that leader, about 100 feet above the ground, it finds a target, and then it shoots back up to the cloud and makes the connection. You're going to see that in a second. Go ahead. Okay, think about the current levels that this thing, I mean, look at it. That's a photo somebody grabbed from their, I don't know, maybe their dash cam. I don't know where they got it, but it's no exaggeration. This has not been photoshopped in any way, I was told by the photographer that took this. Go ahead. So here we go. Step ladder, zigzags, round around in the sky. These are from the NOAA. The leader starts sending down streamers, trying to find a target. It hits that target, the connection draws current, and all of a sudden, at 60,000 miles a second, about 7 millisecond duration, the connection's made, and up it goes, and makes the contact. Next one, Bob. Okay, now this one, we're going to see how this animation works. Watch it. See it happen, it'll watch it again. It'll come a couple times here. You can see the streamers coming down. It's supposed to come again. There it goes. And back up one more time. It should do it one more time. And you can see that when it makes the contact, it's actually going upward, not downward. It's the most interesting video I could find that shows a lightning hit. Kept it for the years. I've had this thing up for years and years and years on presentations. Thanks, Bob. Next one. Okay, here's from a satellite image. You can see the string on the left side of the green, time lapse over 90 minutes, how the lightning moved across the sky to various locations. And on the right side, you can see the image, the spectral domain of the images that went across the US, and just literally as if somebody took a marker and marked it going across. Go ahead. Okay, here's a drawing of it. The initial stroke, you can see there, hits 200 kiloamps, that first one to hit. 200 kiloamps. Give that a little bit of thought. Then you've got an intermediate current that flows up to roughly seconds, and then a restrike occurs again. And that's what got me as a restrike. I didn't get it on the main hit. The main hit hit the power line. The second hit not only hit me, took out the diamond fiberglass antenna I had on the roof of my building mounted. I found pieces for 2 years out in the yard on that thing, all over the yard. I mean, it literally took it out. And it also took out the equipment that was attached to that radio and the lightning suppressor and everything. And that one wasn't switched off. It was on. It was my FT8900. Gone. Okay. So how do you deal with this? You start dissipating it. So here's the ground dissipation of a lightning stroke. Those little fingers almost look like a hand sticking out there. Those are all ground rods out there. You've got the comm building. You've got the bulkhead panel out there. You've got the tower. And you're trying to dissipate the currents. On the far right in yellow, For every ohm of a reduction in earth resistance, you're going to find the current rise reduced by 50 kilovolts. That's been found to be the case. So, and you can see schematically what this really looks like. You can see on the left 60 kilovolts at the tower, and by the time it gets into the house, you still got 15 kilovolts coming in there. That 60 kilovolts, that's at the base of the tower, away from the tower, as it hits the earth, as it's trying to get to the grounds. So 18 kilovolts, assuming 10 ohms to earth. And the only way I can get down to 10 ohms to earth is a ground array, something like you see on the left, with all these rods. Now, I doubt any of us have this many ground rods on a tower. We might have 3. Some may. You pointing at somebody who does? Yeah? How many? 20. There we go. Well, and were you concerned that he's putting in 20 rods? No. And are the guys grounded too? Oh, that's right. That's a freestand. Okay, go ahead. Next one. Okay, we talked about distance apart. On the far right side there are 2 semicircle drawings, and you can see a gray area of concentric overlap in the middle. When the rods are too close together, that area of that blue or grayish color, that is the area of lost. You've just lost that area of potential grounding because the rods are too close together. So just understand that that exists. It's great to put them in, but it's useless if they're closer than the height. They say in the manuals 6 feet apart minimum, but everybody I've ever talked to and the expertise in this always said, whatever length rod, you put a 10-foot rod in, you go out 10 feet. You do a 8-foot rod, you go out 8 foot minimum. And the rest doesn't do you any good to get the maximum type of grounding. The other thing is, here we don't have to worry too much about frost line. In the Midwest, where I came from, the grounds had to be dug deep enough that the top of the ground line, the top of the grounds, had to be down at frost line, 6 to 7 feet down. So you imagine how deep those rods went, because you got up in the frost, area, you effectively lost the ground rod itself and its effectiveness. So the pipes to look down in the top of those rods, took a flashlight and you had a PVC pipe looking down inside there to be able to check out to make sure the connections were still good afterwards before they backfilled around. Go ahead. Yeah.
Placement, 16 feet of placement.
I don't know. Double the length of the rod? Well, yeah. Yeah. Our 56 calls out the length of the rod apart. Yeah. Okay. I'll go back and look at it again, but I sworn it said the same, that they were as long as the rods were spaced, the length of the rod apart was sufficient. So. Yeah. Twice the distance? Okay. I'll have to make that correction on this. Okay. A lot more ground cable too. Yes. Okay. So we talked about this already, the lightning stroke. Remember that the line, the ground rods, electrodes present both resistance. By the way, the conversation we just had here in the room was that a couple of Kurt and David suggested, and Bob here suggested that the first ground rod away from the tower and be the length of the rod away from the tower. After that, it should be double the length of the rod if you're using 8-foot rods, 16 feet. So. Yep. Well, I know In Rib Mountain, which is Wausau, Wisconsin, I don't know if you've ever been there, but the rock is so hard up there, there's no way you can put a ground rod in. If you did, it wouldn't do any good. So up there, it's a big sheets of copper that we took off as much of the earth as we could, smoothed it out, laid out big sheets of copper, and tied it back and backfilled over top of it a minimum 6 feet, so we're down below frost line. It was expensive to ground. More ground rods around the tower base and guy wires will reduce the earthing resistance, which we just talked about. Go ahead. Okay, so what can you do? First of all, a good place to start, and I'll put it back over here to see who's going to take this free one first. If you don't have it, go reach out to ARL and grab a hold of the grounding and bonding amateur radio. I assume this is maybe the first edition, Bob? There's the second now, I think, out. But it's a good place to start. It's not perfect. Read through it a couple times, but it's a good place to start. Book on grounding and bonding. And Bob, did you put it out, Bob? Did you lay the book out? Did you put the book out there? Oh, somebody did. It says free on it. So whoever it is, thank you. It says free. Well, good place to start. Grab it. Next one. Okay, ground the antenna, the support. Ground rods, of course, bond the site ground points. Surge point, protect the AC power. We're going to look into that here now. Create a single point ground to the shack and properly size the ground conductors as short as possible. Go ahead. And whatever you do, possible to steer that lightning to the earth. That's what you're all about. That's what you're trying to accomplish here. Get it to earth. Okay, how about surge protection? What can I do? What can you do to cut some surge out? Because, surge is different ways, different places, in different ways, besides just what we've talked about here. Come in through your antenna feed lines, rotor cables, control cables, power, you name it. There's different ways. Go ahead. Check here. Still under time. Okay. AC power surge protection. There are considered to be 3 types. Type 1, Type 2, Type 3, and Type 4. Type 1, you can go to your utility power company and ask for a surge protector. They'll come and pull your meter, put the surge protector under the meter, and put the meter back on, and charge you a monthly fee for it. You don't own it, they own it. But it's called Type 1 surge protection. I've only seen it used a couple of times. I don't have it. At the load center, they sell these at Lowe's and Home Depot. I have one. It's one of the first things I installed electrically in the house that we moved into. It has to have a breaker of its own. I think if I remember right, it's a 40 amp breaker. It has to go into a double breaker. And it should have the wiring as short as possible. It fastens to your electric panel and as close as possible to the point where your feed hits the disconnect. So it's a surge protector for the entire house. Goes right on the bus. You got to put a breaker in, circuit breaker for it. But yeah, you're going right on the bus. It's got lights on it, lets you know if something's happened to it, if it's been hit, and burns up the devices inside of it. Costs around $70 plus the breaker, whatever that happens to cost. But I moved some breakers around on my panel, was able to get enough space in there to get one in almost right away. Another one is to have, the outlet strip with surge protection on it, a good one, a good outlet. I'm going to show you another one I think is better on the next slide, but anything you can do to cut a surge in your shack at your outlet strip is great. Because these things are throwaway items if they get hit. You're just trying to do something to kill that any surge that might come in. And of course, on the far right side is a lot of times there's equipment with these varistor devices inside to hopefully catch a surge and wipe out a fuse so they don't get any deeper in your equipment. And you can also get these, this one, go ahead, go in there. I think this is probably one of the better ones out there. This thing has got some great noise suppression and surge suppression. Costs about $50 or less on Amazon. I have one on my shack. That's a trip light. Yep, yeah. It's, yep. Yeah, this, yeah, it's, yep. Yeah, this is all metal. It's all metal. It's even got a breaker in it so that if it gets hit, it'll pop the breaker, internal breaker, and disconnect you from the line. So the very first thing in my house is that in my shack is I've got one of these in each of the 2 outlets, and it's got a light to indicate it, so you can look down and see if it's been hit. And even if you got another surge strip in, put one of these in ahead of it. It's a great device. Yes, Bob?
Yeah, you can also get those isobars in a distribution outlet strip, like 6 outlets on it with a pigtail.
You can.
It's an all-metal box.
Yep.
Yeah.
And they're also a lot more expensive, too.
Yeah, they are very expensive.
Yeah,
I've got 2 of them in the shack.
Yep. But
yes, that's right. I was getting ready to say that, Tim, but yeah.
well, it's definitely one I've used on repeater sites too, and wherever I've been, it's one of the first items to go in if there isn't one there. The nice part about this, of course, is that the ground screw, not only does it plug into the outlet, but you pull out the screw and it gets held in place by the screw that you can see above it, and so that if it gets a shock or gets a hit of some kind, it's not going to fall off the wall either. Not that it helps you electrically, but mechanically it's held in place. So easy to get, well stocked, available locally, or however you want to buy it. But take a look at this. I think you'll find it's also got some other things in it, like some VHF suppression and EMI filtering and all of that kind of stuff in it. So I highly recommend it, as Kurt would, and others. Okay, next.
I think every shack should have one of those.
Oh, yeah.
Yeah,
Or
every
a
shack.
couple.
Yeah.
Okay, coax entry point. So how do you protect that coax coming in? Nice if you can do this on the outside of your house. There's various gas discharge SPDs, or surge protection devices. And the little box in the middle on the right, that's the elements inside of it. And if afterwards you want to come up and see what one looks like, the little device that's inside of that after it's been hit by lightning, and I got 3 brand new ones in here, you can take a look and see what they look like after they've been hit. I'll leave it lay on the table up here rather than pass it around. And if you want to go deeper, you can unscrew this one where it was inside of and still see the burn marks inside of it after that the last lightning hit we took. And of course, there are these cheaper ones. They're out there. It uses the same SPD inside of it, same kind of a block. You just take that screw out and you find that same surge protection device inside of here. It's a gas discharge tube. And after I took my hit, here's the little 9-pin connector that took the hit. You see black on it. Wiped it out. I'm lucky that's all that happened. It blew the fuse. I had a 1/2 amp fuse on it, and powering this antenna switch. And it took that out, so I was sure glad that was there in place. But one more button here. What's wrong with it as you see this? What do you see that's wrong here? I know you got to look at it a little closely. Yeah, that's right. There's no ground electrode. Maybe it goes somewhere. I have no idea where it goes. It might go to the ground. There on the far left side, there's a ground cable. It might be for the cable company. Yeah, it might go over and clamp to it. It certainly is not what I would consider to be acceptable for my use if I were putting it in. I mean, it's a great idea to have it, but somebody didn't go far enough. Well, there's no rod though to it. Yeah, it enters the box, but where does it go? No, it doesn't go down. It loops back up. I think it goes over and connects to the cable that's going down to the earth, which is probably the cable company ground, is my guess, but that's all. Anyway, just, those are things you want to look at, think about it. I threw it up there for that reason. Just think about it. And again, the gas discharge items. Go ahead, next one. Okay, other approaches. Hey, there's always a good one. Don't do anything. That's an approach, right? Don't do a thing. It's kind of like people that don't buy insurance in their car. Just don't buy it. Don't worry about it. Let the other guy worry about it. Another one, disconnect everything every time the radios are not in use. Just remember, you got to do it outside, not in the shack, outside. Take the cables off, find a place for them, and pull them away from the house. Pull them away from the shack. So you don't have any means of getting that signal into the house. How long is that going to work? What happens the first time you forget? Just once. Just once. And you will. Okay, I've had 2 lightning hits. One I was home for, one I wasn't. Go ahead. So what are the results? Bad and proper. Devastating consequences. Electrical fires and property damage. How does that happen? Remember I said equal potential? Grounds? You had 2 grounds that are not connected to each other. They don't raise and lower at the same time. Guess what happens? You have 2 voltages that are different from each other. There's arcing between them. Arcing? How do you start a fire? There you go. Need I say more? Electric shocks, potential electrocution, damaged equipment, downtime. Bonding equalizes the voltage and reducing the arc fire damage. Go ahead. Okay, first hit was in 2021. I learned a lot. Turned it into insurance and got a lot of stuff paid for, but I had a $500 deductible. And luckily the insurance company was good to me. Second one, it hit my off-center fed antenna. I came in that way, blew out the antenna switch. Neighbor found it in his yard, the box, literally just blew it, gone, and came in through the switch control cable. The one cable that wasn't protected in the house, the switch control cable. My mistake. Took out the laptop PC, which I didn't mind because it was my old work PC and I had just retired 6 months earlier. So that ended my looking anything up on that PC anymore. I didn't care. So I didn't replace it. The USB hub I was connected to, the coax surge protector, which I have here on the table. You can see it if you want to. The FTM 300 that I had. So how to get to that? Well, guess what? I happen to have left it plugged into the PC for doing some programming on it. So it didn't come in through a coax, it came in through the programming cable. And the video monitor attached. Yes, Bob? No. I fixed it. I actually found the problem and repaired it. Okay, it's in my truck right now. Go ahead. Okay, that's the antenna switch box that I had built after it took the hit. And that's a rotor cable, control cable that was on it, and the relays, what was left of them. That's that 9-pinner up above on the top that was inside. The right side is the switch controller I had made for it. Down below is a polyphaser. This is a good one. I just wanted to show you what's inside of a polyphaser device itself if you've never taken one apart. They aren't the easiest to take apart, but you can pull them apart and replace that element if you ever have to. And you can see the gas discharge tube on the left is the new, and the one on the right is the one that got hit. That's what's laying up here on the table. Okay, go ahead. And what am I doing today? Well, I've gone away from this other switch and gone to the Alpha Delta, because I have more cables coming into the house now. That's the new antenna control cable on the right. It now has a polyphaser in it, also out there at the base of the tower, at the off-center fed in the flagpole antenna. A couple more, and I have a Cat 5. I now have Cat 5 running from the entry point of the house up to my shack for that antenna controller, and I used the Cat 5 surge protector devices, and I have 2 of them. One at my plugged in the back at the bench, or at the shack, and one down in the crawl space. And also inside if you look on the antenna controller On the right side, upper center, you see a little blue kind of sticking out there. I bought a bunch of the firsters in there. So each one of them is protected there too. So I'm trying, we'll see what happens. And I rewired it. I now have 5 relays in there because of the setup so that no coax ever comes through unless it's been switched on. Yeah, I built it, yeah, fine. No, it actually has 4 possibles. What I do is, Kurt, is I actually have my off-center fed as one input. Then I have my flagpole antenna. I can either go direct to it, I can go 4-to-1 or 9-to-1, depending on what band I'm on. And I do that right here. And it works out beautifully, depending on what band I'm operating. And I can actually sit, I'll listen to see what I'm getting the best signal on, and I can actually switch it and just listen. I did it yesterday, and I was listening on 40 or on 20, and I switched over, and boy, one of them was just booming in. And I used it on the 1-to-1 rather than 4-to-1, where I normally would operate that flagpole. Okay, Bob. Okay, there's the house. The lighter tan area to the left is the house itself. And you can see in the upper center, the home load center is there, and a ground rod. It had a U for ground. There's now a ground rod next to it. I have a garage, unattached garage, which most of my antennas are located on. Surge protection device right there on the antenna that's mounted off that garage, which I didn't have before. It's there. It's got its own ground rod going down. It's connected to the ground rod of the panel for the garage, which comes over and it's grounded to the ground rod and bonded also to the house ground. In my ham shacks down below, in the far lower left corner is the entry box. That's where all the cables come in from the crawl space. That panel that has a copper strip where all those SO239s are mounted on. You can see the green cable coming up also. That carries it up to my shack ground. Also grounds all the coax. And then on the upper right side, you will see how the polyphasers are mounted down the crawl space. Yes? Yeah. It's all stranded. It's all number 6 stranded cable. And what I've connected them together with is those bonding strips like they get for electrical panels with the screws on them, with the hard screws. And I actually go down there at least once a year because I'm checking out the space anyway for just generally crawling down there. And like the guy coming around looking for bugs, I'm down there just checking out the space for other stuff. And I go through with a big heavy duty screwdriver and loosen them and tighten them, all the screws on it, just to make sure nothing's loosened up. Yeah. Well, the stranded in that kind of a connector lets you have multiple contacts inside the actual connection that you make with the screw going down on it. So it's getting multiple surface areas as compared to the solid, which has only got a couple of contact points. So I prefer the stranded over it. And you can see I have a ground rod outside the house there also, and that's all bonded. Everything's bonded together. And I have a separate ground rod out there at the base of my flagpole antenna where the other ground is attached, but I don't have it bonded. That's over 50 feet out there to that flagpole antenna. And so I don't have those two bonded. Go ahead. Okay, questions. This is an AM tower site. I'm sure anybody in the AM world will recognize the mat that goes down on a site and some of the various connectors. What's that, Bob? Yep. Yeah. And if you want to go to the next slide quick, this is this is a site that I had to go in and we had to reground that site because we were putting a 700 megahertz antenna system on it. And we found that the grounding was improper. We were drawing a lot of current off that hot tower, shunt-fed tower. And we ended up having to have it all dug up and put a mat down. And you can see a guy in the third image over from the left to the right. He's silver soldering the mat to the strapping. And they wanted me down there to watch it being done to make sure, because the guys that were doing it had never done anything like this before. The worst part is I hadn't either. But I knew what I was looking for. And on the right, connecting to the tower, how do you connect copper to steel? That was an interesting too, because the copper strapping got wrapped in a bimetal type of material that wouldn't corrode, and then anti-corrosion material put on it, and bolted to the tower itself. So, questions? Yeah.
What is the easiest way of driving an 8-foot ground rod in the ground?
Well, easiest way is go borrow the tool from Kurt. Kurt has a great device that's actually to drive with, and I think you got one.
Yeah.
Here, want to explain it? Go ahead.
It's a device that I should have brought it actually. Yeah, and you just slip it over the ground rod and you raise it up and drop it. Just raise it up and drop it and drop it. The other thing is you can, if you got a hammer drill with a ground rod, you have to buy a special ground rod bit. Yeah, the cup. Drive it. Metal fence post driver.
That's what I use. They're about this big around.
That's what that ground rod driver is. It's kind of a fancy one of those in a way. Used water. Yeah. What was that again, David?
We took a water hose and just set it there we get the water, let it run, and just work it up and down, and then take a sledgehammer and drive it the rest of the way down.
Okay.
So, you can fight it.
Going to Tim.
Saying most electricians have some way of doing that. The ground rod that I have at my shack was put in with the driver drill. The guy that did it has done all my work for years, both residential and commercial, and did a great job. And very, very familiar with the AM tower project there. One of my first tasks when I went back to WIVK in 1998 was our AM 990 facility had lost most of its ground, and we had to redo that. I was fortunate to have the services of Frank Folsom, some of you guys may know, W4TEG, who basically took that project on and worked it start to finish. And not only that, but not only are you protecting yourself from lightning damage here, but in the AM radio world, the ground reference will determine how well your AM station gets out.
I will say that, I had to do it because we were putting a 700 megahertz array on this thing for public safety. However, the owner who had just bought that station couldn't hear it at his house. Afterwards, it was booming in better than any of the other stations. And he directed his telecom consultant, his communications consultant, consider regrounding all my stations.
If you drive down Kings Highway in Myrtle Beach and poke up AM 990 at night, there's a very good chance you're going to hear it. I can speak to that personally. Not too long after we got all that work done, remember, I'm Tammy's lackey. So the boss here and I were driving down Kings Highway to Myrtle Beach, and I dialed over there because at the time we were doing a Vol Network show that was in studio. I didn't have to be there. And I said, "You hear that? That's my station. That's great." She said, "That's nice, dear. We're on vacation. I want some music."
Okay. Any other questions? Anything from out there in the field? The hinterland looks like.
I just want to comment too.
Yeah.
Years ago, I bonded my station ground to the electrical ground at the house, and 16 feet apart was a ground rod, and those were CAD welded. You can I recommend CAD welding. You can get them from DX Engineering, and dig it, put it in the ground, and cover it up. You're done once and done. The other way to do it is have a ground rod and a clamp, and I recommend that you put, maybe if it's in the ground, get you a PVC, like a 4-inch cap or something, and put over it. make that a serviceable ground, whereas you pull the cap off and inspect it, make sure it's tight every once in a while, every year or so. But always those clamps to a ground rod, inspect them in your home, tighten them up.
Mine aren't CAD, but they're, I've got basically a 2-inch PVC about, I don't know, maybe 8 inches long. It's been sliced on the sides for the ground cable to come off the side with a cap on top.
Yeah.
That's down over the side before I backfill around it, so.
Yeah, make it a maintenance area.
So big thing is to have it, and make it, any connections you have on it to make sure they're there. And, okay, I'm going to offer something else here too, and I think Bob will go along with this. We've done grounding. We've helped other people in the club here come out, look at
Sure.
what you have, help you what you could do, what you can do, and help you do it too if it comes down to that. So don't
right.
be afraid to reach out. We've got enough members, we've got enough experience here that people are not afraid to come help do it and get our hands dirty. Right, Kurt? We've all been there, we've all done it, and we're not going to be afraid to help you. So don't be afraid to reach out if you need help.
Yeah, Steve Sharp and
Yeah.
Kurt come out and help me, and I'll tell you, it's great. A lot of fun. Wow.
Thank you, Dave. Thank you very much. I learned some stuff, so that was good. How about we take a 10, 15-minute break? We'll come back at 8:20, and we'll power through the rest of the meeting. All right?
Hey, Dave. Dave? Scott on Zoom. I'm on Zoom.
Go ahead.
Hey, just one thing, anybody that has trouble sleeping at night, when I was working at the power company at our comm sites, we had to ground everything to the Motorola R56 standard, which I know Dave is familiar with. The manual is 518 pages long on how to ground comm sites. So if you're bored or can't sleep, there's some good material to read.
And I had a printed copy of the latest version up until about 2 months ago when I started cleaning house. I still have it electronically if anybody really wants to see it.
Yeah, it's available online. Just search for Motorola R56, and they got a PDF on there, and that's what I was just looking at while we were doing this. So.
Thanks, Scott. Tim is asking if anyone has not signed up tonight at the meeting here. He has a sign-up sheet over here on the right by the door. Please sign in.